Hello, welcome to Chapter 7, Section 1, Exponential Functions, Growth and Decay. We're doing the guided practice problems that are practice for the homework and the questions we're going to be putting on the summatives. So in this example, we're going to be given exponential functions, and we're going to try to figure out if they're growth or decay first, and then we'll make a table and then we'll graph it. The numbers are going to look a little weird, but that's okay. We'll talk you through it. And again, I'm making the video to explain how things work, but of course in class we go back and forth between doing it live and in our heads versus doing it with the calculator. So I know that, like, sometimes it gets a little complicated. You can do things with the calculator, and you don't even need one like this. Okay, you can. I don't have one actually. I don't know if this one works. Yeah, maybe it does. Clear. So you could actually get rid of that. You could do 32 times 1 and get 32. Then you can do 32 times 0.5 to get 16. And then you can do that times 0.15 again, and you can keep working. I don't even know if you can see that, and the lights aren't showing up. So if you have like a basic calculator, yeah, you can do it. It's not going to be that hard. First of all, is this going to be growth or decay? So my general form is going to be a times b to the x power. So what's my b? In this example, my b is going to be 0.5, which is less than 1. So this is going to show decay, which basically means it's going to start high on this side and it's going to come down but never touch 0 as it goes to the right. That's what decay means. Let's try to come up with some let's try to come up with a table here. We'll keep it kind of simple. Here's my x, so I'll do -3, -2, -1, 0, 1, 2, 3. And of course this is going to be 32 times 0.5, which is 1/2 to the x power. Kind of ran out of room there. It's basically that. Okay, how do you make a table easily? Start with 0. 0.5, or 1/2 to the 0 power, is 1. 32 times 1 is 32. So when you graph this, the first thing you do is graph the y-intercept. That's the y-intercept. That's where it crosses the y-axis. So it crosses the y-axis at 32. Here's 20. What are we going by? 25, 30, 35, 40. Right. So 30 is right here. 32 would be about right there. Okay, cool. Now we do x equals 1. Okay, so, and I made a big graph, so I don't have a lot of room to write. I'm basically showing you what's in my head. So if I do 1/2 to the first power, I get 1/2. 32 times 1/2 is the same as 32 divided by 2. So that's going to be 16. And I'll write it up here. This is 32 times 0.5 to the first power. So basically that's 32 times 0.5. And you can, even if you have this calculator, this is 32 times 0.5, 16. This is I don't know, like a business calculator. That's why it's given to me in decimals, because it thinks I'm doing money. If I do 32 0.5 to the second power, that actually means you're supposed to do the exponent first, but I want you to think of it this way. 32 times 1/2 times 1/2 again. So I take 32 times 1/2, which is 16, and take half of that, which is 8. And then I take half of that, which is 4. All right, got it. Now let's figure out the other side where the exponents are negative. Okay, so what does 0.5 to the -1 power mean? Well, if I think of it this way, this is where fractions come in. This is 1/2 to the -1 power. and that is the reciprocal of 1/2, which equals 2. Of course, that just takes care of the exponent. I also have to multiply it by 32. So this is 32 times 2, which is 64. Now, does that fit my pattern? As I go down on my table, which means my x's are increasing. I know, my x's are getting bigger, just my table is this way. I go 32, half of that is 16, half of that is 8, half of that is 4. But if I turn around and go the other direction, I'm doubling. 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So now I'm using my pattern here. This should be 128, and this should be 256. Let's go to this calculator and see if I got it right. Yeah, I don't need that. Okay, so I go back and I set up my function. I do 32, and I'm going to do parentheses. I should have been doing parentheses the whole time. 0.5 to the power of x. Let's take a peek at the table first. Oh, and I left it where it was last time. Let's get back to here. So here's 0 is 32, like I said, right here. 1 is 16, 2 is 8, 3 is 4. So everything looks good. Let's go the other way. -1 is 64, then 128, 256, 512, and it keeps doubling. Okay, so let's try to plot some of these. I already got 0, 32. Let's do 116. Notice that this right here is 1, and this is 3. I kind of stretched out the x-axis. So 1 gives me 16, here's 10, here's 15, 16 is about right there. 2 gives me 8, which is about right here, and 3 gives me 4, which is about right here. So it looks like my graph is curving this way. And even though I didn't go far enough, remember, this never touches, it never goes to 0, so don't let that cross the x-axis. Excuse me, I gotta get some water. I am sorry to do this on video. What about going the other way? Well, if I come over here to -1, I need to go up to 64. I don't think my graph goes that high. Here's 40, 45, 50, 55, 60. 64 is going to be up here. So maybe up here someplace. So my graph is going to go toward that. And remember, no arrows. And this never touches the x-axis. The graph never equals 0. And this never goes perfectly vertical, because the x's are going to keep decreasing. Next time I'm going to have -2, then -3, then -4. It's just they're going to be way up, way up off my graph. Excuse me. Okay. Number 3. Same thing. My coefficient is 0.5, or 1/2. And my base is 1.2. This would be the same if I used fractions. 1/2 times 6/5 to the x power. Now, why is that useful? Because I start with 1/2 times 1 when x equals 0. Then I would do 1/2 times 6/5. Then I would do 1/2 times 6/5 times 6/5, because that would be 6/5 squared. And then I'll do one more, 1/2 times 6/5 times 6/5 times 6/5. So you can kind of see what the pattern is here if you use fractions. I don't think decimals really get to it, but maybe not, I don't know. If I go the other directions, then I gotta start using reciprocals. This would be 1/2 times 5/6. Keep that in mind. All right. First of all, is this, and did we say this with, yes we did, sorry, couldn't remember. Is this exponential growth or decay? This is going to be growth, because 1.2, or 6/5, is bigger than 1. So let's kind of sketch out a table here. 0.5 times 1.2 to the x power. -3, -2, -1, 0, 1, 2, 3. So, if I let x equal 0, any number to the 0 power, except for 0, equals 1. This is just 1/2 times 1, which is 1/2, or 0.5. Right, cool. If I let x equal 1, which that's 1/2, If I let x equal 1, I get 1/2 of 6 over 5. The 2's kind of reduce, and I get 3 over 5. 3 over 5 is also 0.6. Make my 6 a little bit better. And then I can start doing this and doing this. But again, I am fully well aware that you are probably going to use one of these. So let's do it. 0.5 times 1.2 to the power of x. Let's look at my table. Okay, so here's 0 that gives me 0.5, and 1 gives me 0.6, and 2 gives me 0.72, and 3 gives me 0.864. Yes, it is increasing. It's not increasing a lot though, okay? It's a good thing I picked my graph this way. So 0 gives 0.5, this is 1, and this is 3, so 0.5 is right here. 1 gives 0.6, which is just a little bit higher. 2 is 0.72, which is just a little bit higher. And this is not quite at 1 yet. Now going the other direction, -1 is about 0.416 repeating. And this is 0.347222, I'll just round off, and 0.289. So it looks like, excuse me, it's doing this. And man, if that doesn't look like it's almost a straight line. But it's not. It's not a straight line. If it was a straight line, it'd be 0.5, 0.6, 0.7, 0.8. But it is increasing. And the other way, the other way works too. So my graph does show exponential growth. And the same thing, this never goes perfectly vertical, which is kind of obvious it doesn't. This never touches 0. Let's graph it. I think I need to change my window from where it was before. Let's graph it and see what it looks like. Excuse me. Yeah, that doesn't really show much. So if I change my window to like maybe -3, 3, -3, and maybe we'll go a little bit higher. Maybe we'll go 6. Now let's graph it and see what happens. There you go. Now you're going to be able to see a little bit more. I guess 6 would have still been too much, but that kind of shows what's going on. And again, Desmos is your friend. All right, and let's see. Let's do one more. And we'll pick up the speed on this one. Again, this is a times b to the power of x. That means that my b in this example is going to be 3 over 4. Since 3 over 4 is less than 1, this is going to be exponential decay. And I'll just go ahead and cheat by using my calculator. Clear. And let's just gotta, whoops. I know you can't see what I'm doing right now. I'm just clearing out what was there before so I can quit. All right, so let's go to y equals, and we'll say 0.4 times, I'm gonna go ahead and do 3 divided by 4. I know that's the same as 0.75, that's okay. To the power of x, and let's look at our table. All right, so these are the things you should be able to do in your head. And when we're actually going to go into this a little bit more when we get into transformations of exponential functions, which comes later in the chapter, right? So that's why I'm kind of like we're just learning this for the first time, so that's why I'm kind of letting the calculator do the heavy lifting. But still, everything is the same as what we had. Any number to the 0 power, except for 0, equals 1. So this is 0.4 times 1, 0.4, which is what it is right there. And then if I have, just show it up here, 0.4 times 3 divided by 4. All right. If I change that to a fraction, that's the same as 4 over 10 times 3 over 4. Those 4's are going to reduce, and I just get 3/10, which is 0.3. And if you look at it, that's what I have. So, okay, it's a reasonable expectation that you should be able to come up with a couple of these in your head. Okay, it is an accelerated class. The rest of it gets a little hairy. So this one is 0.225, and this is 0.16875. And if I go the other direction, 0.53, looks like it's 53 repeating, 0.71 repeating, and 0.94815, etc. And if I graph this, man, I really should have picked a different window for my graph, because these are all going to be really, really, really small. My graph is not going to look pretty at all. This is 1, so 0.4 is about right here. 0.3 is about right here. 0.25 is here, and now I'm getting really low. So this one's going to look like this. Whoops, sorry, I kind of bubbled it. Oops. But again, this never touches the x-axis. Going the other direction, now I'm like right about here, maybe about right here, and now I'm getting close to 1. So it does look, move this out of the way, it does look like it's starting to curve upwards. Let's see what the graph looks like. I don't even know if I can see the graph, the other part of it. So it's going to look like that. So yes, this is going to be an example of exponential decay. What is exponential decay? When you go to the right, when the x's get bigger, if the graph goes down, that's exponential decay. If I look at this one from the previous example, if I go to the right and the graph increases, this is exponential growth. Okay, we'll see you in the next video.